Hi, everyone. Wow, right? My name is Joanna Milenchik, and I'm the Associate Dean of Undergraduate Education in the College of Engineering at the University of Michigan. And it is my pleasure to be here today and introduce the next team, the team from Gwydion Inc. What happened was about a year and a half ago, I was looking for a new way to develop tools for my classroom. I teach material science and engineering in the College of Engineering, and one of the really hard things to teach is crystal structure. And I was thinking, I've seen Pokemon Go, and what if we could take Pokemon Go, that idea, that augmented reality kind of idea, and bring it into the classroom and make these virtual reality models that the students can use. And I was introduced to Duncan via this enormous Michigan network that we have. And we began to work together, Duncan and Paul and his entire team. And now, today, as a matter of fact, we've got prototypes in the classroom, and I couldn't be more excited for them. So I just want to bring up the guys, and I hope that you are as impressed with them as I am. Thank you.
I'm glad some of you appreciated the song there. So my name is Paul Stefanski. I'm the co-founder of Gwydion Inc. Gwydion produces virtual reality and augmented reality technology. And I'd like to talk to you today about 3D information. We live in a 3D world. Everything that's coming at us from all our senses is in 3D, except when it comes to those 2D laptop screens, phone screens, televisions, even pen and paper. And that might not sound like something that inherently causes a problem, but think about industries where the 3D nature of what they're working on is what produces the value. Industries like architecture, or Joanna's material science, or even pharmaceutical research and discovery. Take a look at this spinning ballerina. This is a 3D rendering, a 3D object, but it's on a 2D screen. Now, what's funny about this is that half of you will see her spinning clockwise, while the other half sees her spinning counterclockwise. And if you're really good, you can even get her to switch directions. This is just a small example of many illusions that can happen when something that's supposed to be 3D is forced into a two-dimensional interface. And those illusions are actually costing companies billions of dollars every year in wasted time, resources, and brain power. Let me give you a more specific example. I met João Rodrigues several months ago. He's a researcher in pharma R&D at Stanford University. And he was working on a project for Pfizer with partner labs from around the world. Now, whenever João or any other researcher like him found something important with the 3D models that they were working with, those protein models doing protein docking, they would have to load up that model in a 2D viewer and then use a screen sharing program like Skype or BlueJeans, programs we're all familiar with, and use just that little 2D window, their mouse, and his voice with a 2-second delay to try and portray everything that he'd found. João and every other researcher like him spend over 500 hours a year with this type of information reporting. And despite all of the time that goes into that, the results are less than impressive. In fact, just last month, João had to fly out to Israel because his colleagues at a partner lab there misinterpreted a simple protein switch that he was working with. What happened was an atom that was in front of one appeared to be behind it. And neither party had any idea that they were misinterpreting the information. They had no way. They were looking at the same thing. What João needed at the time is something like we've all seen in popular science fiction. Take this example of Han Solo, looking at a map of the galaxy. It's projected in front of him in a 3D. He gets to work with it with his hands, rotate it around, point at what's missing, show his friend, Rey, exactly what they're looking for. It's intuitive. It only takes seconds. And if João had had that opportunity with the protein switch, the 3 months of lost time that Pfizer lost on their time to market with their new drug would never have happened. We've built a platform that delivers this solution. It's a virtual reality and augmented reality platform called Arthea, and it lets users upload 3D information of any file type. And we convert it on our servers into a VR accessible format. From there, you can load it up on any VR or AR capable device, like Oculus, Vive, iOS, Android, and many others that new companies are working on every day. Then, our manipulation tools allow these users to work with their content however they want, often with even more precision than would be possible with a real model prototype in real life. But the most important part is a feature that we call linked view. And that is what delivers that sci-fi solution that you saw in the photo before. It lets users bring in any other user on any other device in the world in real time and work with them face-to-face on their VR 3D content with no delay, and every change, every annotation is perfectly seen by everyone who's in the same session together. When it comes to expanding Arthea, we're looking at pharmaceutical research and discovery paired with education. These are two inextricably linked markets. Over a quarter of the funding that goes into pharma R&D goes through academic labs. And in education, we have access to every use case with 3D content. When you look at this market set, over $8 billion a year is spent on visualization software. And right now, that means software like Zhao is currently using, costing him all that time and causing mistakes with him and his colleagues. If we were to get every student in the US and pharma R&D researcher on board as an Arthea user, we would be able to achieve over $2 billion of annual revenue. And that's all done through a simple annual SaaS platform. It's charged per seat to whatever institution the user is working for or learning from. And we know it's not feasible to get every single person on board, but our traction so far has been fantastic. Like Joanna said, we started at the University of Michigan several months ago, where they paid for access to our first prototype build of Arthea. Since then, they've signed up with renewed contracts and new classes and labs to get access. But the most exciting part is that when we gave a demo to the new provost of the University of Michigan several months ago, a man who spent his entire career so far working in neuroscience and public health with 3D content, he was so excited by the potential of the platform that he pledged to roll it out at the entire University of Michigan in 2018. Now, we're not alone when it comes to visualization and virtual reality. But when it comes to our competitors, visualization is where it stops. Gwydion's the only company that has developed a platform that offers those tools that we have realized are the most important parts of getting your content in 3D. That's being able to get any type of information that you want to be working with into VR. That's being able to manipulate it in any way that you want. And of course, the most important part, being able to bring in anyone else from any device in real time. We're the only company that can offer that right now, and our competitors are all a minimum of 12 months behind us. And it's our team that makes this possible. I'd actually like to point out Zhao Rodriguez first. He was the fellow from the story I told at the beginning. He was building his own VR solution for this problem when we met him, because he realized that VR was the best medium for the problem that his industry faces. When he saw what we were building, he dumped everything he'd done, picked up Arthea, and signed on with us as an advisor to help us scale in the pharma R&D industry. The rest of us have been working together on virtual reality platforms and programs for several years. We actually started by making video games, one of which we raised over $15,000 on Kickstarter, and another we built for physical therapy purposes at Mott Children's Hospital. We want to take advantage of our great team and our lead over our competitors to push into big research universities as aggressively as possible. And from there, use that link between academic labs and commercial labs to land enterprise contracts with big pharma companies. Our ask today is pretty self-explanatory. We're looking to grow. So we need contacts who can act as champions in their institutions. That's research universities, classrooms, and of course, commercial pharma for enterprise contracts. But lastly, I'm really proud to be able to tell you that we have committed over $200,000 on a note round that ends on October 15th. So we need introductions and advice for fundraising, because every dollar that we get right now translates directly into faster growth. I'd like to thank Desai for making all of this possible. I'd like to thank all of you for your time. Thank you very much.